Hello folks, today we are going to solve the lead code number 1 problem, which is very popular problem, two sum. Okay, a statement given that given an array of integers nums and the integers target, and they return the indices of two numbers such that they add up to targets, and you may assume that each inputs have only one solution and you may not use same element twice. Okay, so you can return the answer in any order. So there is a example given the inputs nums 2, 7, 11 and 15 and target is 1. So the output is 0 and 1, yani it means 2 and 7, and okay, it return the indices 0 and 1 means 2 and 7 element. Okay, so explanation, because 0 nums of 0 plus nums of 1 is equals 10, so we return 0 and 1 as we go through the two example number 2 nums 2 3 to 4 and target is 6, so the indexes will be 1 and 2, so it will 2 plus 4, so it will be 6. Okay, so constraint is the length of the array will be more than 2 and less than 10 to the power 4. Okay, and the number may be in negative and the positive, and target also may be in negative and the positive. Okay, so let's okay, so one two sum. Okay, nums 2, 7, 11 and 15, and the target is equal to 9. So our first approach is will be the brute force approach, in which we use two nested loop which iterate windows. Okay, iterate the arrays like from this, okay, then this, then this. Okay, so like the from 1 2 and 7, so its target is equal to, yeah, true, then it checks this and this like that if it not found the answer. So here is like 4 I to n, and yeah, the 4 j to j equals to I or j to n, and like we check here if there is if a statement, if nums of I plus nums of j equals to target, if it is true, so return the new array with indexes. Okay, I and j here, yeah, like this. So our approach will be like this, but there is a problem with there. This approach takes time complexity n square, like the first for loop takes one n time complexity time. Okay, and the second is also n, so it will be n into n, so it n square. Okay, so we have to optimize it. Okay, so when we are going to optimize, we do some mistake while doing that, like we saw this array. Okay, so we thought like, yeah, it's in the sorted array, but as a statement never said it, the array is in sorted order. Okay, so what we do here, and what are the mistake here, like we use binary search. We implement or a binary search, okay, binary search, in which our first pointer is, and using two pointers, all we know that, like in binary search always we use, mostly we use two pointer. So our j will be here and the our I will be here and j will be here, and it check it's the sum of these I and j elements is equals to the target. Okay, so no, it's not equal to target. It is greater than it's a 17. So what, it's a greater than the target. So what we do, we move left, like we decrement our j move to the left, and it check it whether it is greater than or less than. So it is still greater than the target, it will be 13. So our pointer moves from here and it will check it is equal or less or greater. So yeah, the target is equals. So we got the answer, so it will return our indexes. But what if the binary search fails, where like our array is like 7 2 3 4, okay, and let's assume our target is 6, okay. So it's how we identify, like where we have to move, like from the right move or the left move, because our we don't know where is the element is bigger and the small, okay, so we don't know. So they show here the binary search fail, like it's our j is here, I is here, so it's 11, but we don't know whether the left side is less than or greater than to the this element. So we can't consider where we have to move, like from the right or we have to left. Okay, so binary, for to implement binary search we needs the sorted array. So what we have to do, we have to sort the array. Okay, we have to sort the array. But what is the problem here? Yeah, we got the indices, but the indices will change. Like first the indices here 1 2 3, okay, and when we sort it, so it will 2 3 4 and the 7. So here indices is 1 2 3, okay, but like in the three indices, the element is not match, so our answer will not correct. Okay, so here the binary search is fail. So what we will do there to optimize it, we use map. We use map. Okay, so in map, what in map, like this question, we go through this question, what we so like nums is 2 3 and 4 and 7, okay, 7. So and the target is 6.
Hello, Moto.
So yeah, so first, like our we use for loop. I started with j and with the n, okay, and we calculate here the complement. Okay, like complement is what, like whether the current element minus the target is content in the map or not. It will, if it is content, so yeah, our answer is that. Like let's go through that. Okay, like in the map we store the current element with the indices, okay, like that. Okay, so like here we have the map with the values and the indices. Okay, so like a target from yeah, so like target minus the nums of I. Okay, target minus nums of I. Yeah, nums of I. So first nums is 6 minus 2 is 4. Is there any 4 in our map? So no, there is no 4. So our cursor moves to here. Okay, and the 2 will be here and the indices will be here. Okay, and then again it 6 minus 3, it will 6 minus 3 is 3 contents in the map? No, it will not contain in the map. Okay, so 3 will update it here and the indices is 1. Okay, now our cursor or indices moves here 4. So 4 minus 2 or 6 minus 2, it will be 2. So is there any 2 in the map? Yeah, so there is 2 in the 0 indexes. Where? In the 0 indexes. Okay, so we found the so like we check here the map contents key as complement is content. So yeah, if it is true, so it will return new array. Okay, so indexes and this indexes will be map dot get complement. Okay, map dot get complement that gives the indices. So it will be return 1 sorry I will be what 2. So it will return 2 and 0. So our answer will be this. I hope you will understand. If any queries, let me know in the comment section. Okay, thank you for that.